All right. Hello, everyone. My name's Jonathan LeBlanc. I head up global developer advocacy for PayPal and Braintree. Some of the things that we've been working on for the last year and a half, maybe even a little bit more, have been around beaconing technology. So really working with Bluetooth Low Energy as a specification, working with hardware on top of that. A lot of our focus has been directed around really how to change shopping, commerce, in-store experiences, and tie offline with a lot of the online mechanisms. So tie in an API with a physical shopping experience. That's what we've been looking at. Now, what we're going to look at today when we're talking about beacons and we're talking about working with them and interacting with them in a physical space is we'll take a look at really what the beacon is made up of, the little pieces, a little bit on what you would actually use them for and what is probably not the best to use them for. We'll also look at deploying them, because deploying them is one of the trickiest things. When you're actually putting them around a space, depending on the building makeup, depending on where you're placing them, it really affects the signal that you're going to get from them. And with the signal issues, you might run into things like the inability to accurately figure out a proximity. Then we'll actually look at baking these into some Android applications so that you can start working with them, start playing with them. For the most part, what we'll be looking at and playing with are estimote beacons. So they're part of Apple's iBeacon specification, and a lot of the beacons that you'll see out in the wild are pretty much built on that. So we'll take a look at those. I also have with me an experimental PayPal beacon. This is one of our early prototypes. It's ugly as sin because it's a prototype, but we'll talk a little bit about this as well. But for the most part, we'll focus on programming on top of an estimote beacon and taking a look at everything like that. All right, so how many of you here have worked with beacons before? Okay, a couple of you. And how many of you know what a beacon is? Okay, so for those of you who don't, a beacon, you can think of it kind of like a small-scale microcontroller or a computer with a Bluetooth Low Energy shield on top of it. Very easy to build your own. We've had a number of people, a lot of our folks as well, that have built out their own, essentially out of an Arduino, a Bluetooth Low Energy shield, and a little bit of programming on top of that. The vast majority of the beacons that you'll actually find in the wild are built essentially with those capabilities. For the most part, they're meant to be paired with mobile devices as kind of a mobile-centric view. So you would have your mobile device, which would connect because the vast majority of the modern smartphones nowadays do have Bluetooth Low Energy receivers and transmitters baked inside them. Very cheap hardware when bought at scale. So most of the phones that we're using nowadays will have all that hardware available to start working with beacons and start manipulating them, interacting with them in a physical space. So the beacon in and of itself is, you can think of it just like a lighthouse. It's telling you where it is. So on a regular basis, a beacon would broadcast out saying, who's around me? Well, essentially what devices are around me that can understand. That broadcast is actually called an advertisement. That's the terminology that they use. Now, when you advertise, you're basically saying, who's around me, but those phones, those devices that are in proximity, we can trigger off events based on that. So think of it as location-based triggering of events. Some beacons go a little bit beyond that, like the PayPal beacon. We'll take a look at how that works a little bit. That one incorporates Wi-Fi as well and goes beyond just broadcast, and it also accepts a lot of data coming through directly to an API. All right, but the vast majority of the capabilities on this are all about being location aware. So most of us will be familiar with location-based systems based on check-ins. So Facebook check-ins or Swarm check-in or just broadcasting out your locations. Beacons are nothing like that. They are all about your physical location in the given space. So as you're walking around a space, the beacon's advertising out and knowing approximately where you are. They're not 100% pinpoint accurate when it comes to indoor locations. So just be aware of that. It's going to give you a fairly good proximity. And depending on how you deploy them, they can get to about a good meter within a range as far as accuracy. But
deployment is key when you're dealing with a lot of these. Let me give you a real world use case. So these PayPal beacons, when they're actually deployed in the wild there, the way that they were built is very similar to the iBeacon specification, but it takes it a little bit further. It's a proprietary approach on the PayPal systems for commerce. So a merchant, let's say we have a pop-up store. Someone sets up a pop-up store and they want to begin selling things. It's just in some random parking lot. They're running off of MiFi for Wi-Fi capabilities, which would connect to the Wi-Fi capabilities in this. And they have just a little register that they might have on an iPad or a Nexus tablet or anything that they really want to use. So the person who would have a PayPal application would walk into the store, and all of a sudden the PayPal application would wake up. It would say, oh, hey, you're in this store. Would you like to actually check in? Because it's in the range of that beacon. It's within about 75-meter range of the beacon. If you say no, no information gets shared, you don't get checked in, no information shared with merchant or with PayPal or anything like that. If you say yes, though, what's going to happen is an encrypted message is going to go from your phone to the beacon. The beacon is going to transfer that directly to an API endpoint, in this case PayPal APIs, and check you in. The encryption-decryption happens through public keys that are baked into the application itself, so that's how we decrypt the message. And if you're dealing with any personal information, any payments or things like that, everything has to be encrypted because beacons are not meant to be secure as of the hardware themselves. So just be aware of that. Do not send clear text messaging through of personal information. It's not meant to be that. So when they actually check into the store, what happens is they will walk around, they'll pick out what they want. They'll go up to the person with the tablet and say, I want to check out with my PayPal account. They push them through because the merchant has their name, their face, and the ability to check them out right there. So that's how that beacon works. So you never touch the wallet, never touch a credit card, never touch anything, you just walk right out. Beacons in and of themselves can be extended that way. And this is the only time I'll go through really that procedure of this because you can see the capabilities that you can actually extend upon a beacon. Now, the reason why we're looking at estimotes and why we're looking at iBeacon specification is because that's what's in the wild right now. That is what is prominent in the industry and that a lot of companies, a lot of startups are building upon. That's why we're looking at these and programming against them. So how it's generally going to work for the vast majority of it, and I've gone through a lot of this already, but iBeacon specification will work within these two parts. You would have a beacon hardware that would advertise out saying who's around me, and it would basically be broadcasting, and based on the broadcast or signal strength of the power of the broadcast, that's how we're able to determine its proximity. It's not going to tell me it's in that direction or that direction. It will tell me I'm approximately 5 meters away from the beacon. That's how it's going to work as far as proximity detection. So that's why deployment is key, because if you deploy something out and it's 75 meters, you don't know where the heck in the store they are. But if you deploy it in an aisle, for instance, and you're walking down the aisle, and based on, let's say, someone's shopping habits, I know, hey, they like this particular type of bread. They just walked by that bread because they're a meter away from the beacon. Then I can say, here's a coupon for that, because I triggered it off on the application that they have installed. Those are types of things that you can do. But that's why deployment is key, because you have to trigger off based on these events, not just broad location of where you are in a physical space, because that's not going to work so well. On the PayPal beacon, as well as some of the other proprietary beacons that are out there, you're going to be looking at this last piece as well, where instead of the beacon just being a broadcast mechanism, what it's actually doing is working as an intermediary bridge between the phone or smartwatch or what have you, and the endpoint. So this could be hooked up to basically anything. And really, you're building one of these things yourself, Arduino, Bluetooth Low Energy Shield, Wi-Fi Shield, nice little sandwich board, you have your capabilities right there. It's not really all that complex on the hardware side. Vast majority, I'm looking in the wild. The vast majority of the beacons that I'm actually looking at and the ones that I've seen deployed in industry standards and startups, a lot of people that are working on them, are right here. So the estimote beacons are the ones that most of us in North America as well as Europe tend to use. They're some of the more costly ones, they're about $33 a piece. They're sold in packs of 3, 400. But they're doing some very interesting things, including their future stickers, estimote stickers. So very, very thin little stickers you can put on somewhere, so it's not clunky like this, it's completely flat. So they want to embed sensors in there like this, temperature and motion sensors that are already baked into an estimote, and make those applicable to the bottom of a shoe or something. So just a different way of looking at beacons, but they're doing some very interesting things. Now these sensors, I'm going to be completely blatantly honest with you. They're not that useful. Temperature sensor, this thing has like a little board inside, and as well as the temperature sensor, and when you actually deploy them, the temperature sensor is about a couple of degrees actually hotter within the silicon shell, so it's not fully accurate. And the motion sensor, if you're indoor location, it's hard enough to actually pull a location if it's standing still, because you have all the signal interference and signal degradation that's going on in an indoor location. So it's hard enough just to find the actual approximate location. If it's a moving target, completely other story. So the sensors themselves, not that valuable as they are now, but they're there. Blue Cat Beacon, it's pretty much still going through trials. They'll probably be around the $80 to $95 range when they actually get it deployed. Our dev advocates out in Australia are working with those because they have a lot of their folks out there in Sydney. But the one good thing about them is that they run off AA batteries as opposed to a coin battery cell. So the estimote, it has this awesome, really nice looking silicon shell. It looks aesthetically pleasing when you put it on something. But if you try to replace the battery, which I'll get into in a minute, it's a little bit tricky. You have to use some of your maker skills, as some of the representatives had said. And maker skills mean destroy the beacon. But Blue Cat's running off AA batteries, when you're actually deploying this into a physical space, it is really nice to be able to change the batteries on a regular basis, especially if you're advertising out on a regular basis, and let's say your battery life is about 6 months or so, on regular intervals, advertising intervals. These gimbal tags, pretty much anyone I see working with beacons has a gimbal tag. Things are $5. You can deploy them, lose them, throw them anywhere. They're set up to be bounced around. So they're not that great as far as having dashboard functionality or cloud functionality like the estimote beacons, where you can configure a lot of the details about the beacons. But they're $5. So if you're getting started with beacons, it's a great way to start doing it. Now, most of the stuff that's built off of iBeacon specification, it's very similar. So the methods within it, the class structures, they're very similar. But they're built by Apple. So if you look at the vast majority of these out here, you go to the documentation for iOS, it is stellar. You have great demos, you have great videos, you have everything that you might need to start working with it. Android samples are a little bit iffy. So you'll usually have a couple of lines of code out there. You'll have maybe an example and Java docs. So you're basically working in Java docs, but come on, who of us are not used to that? So that's what you're going to be pretty much working with a vast majority of the beacons that are there. And then Contact.io, the reason why I included this one, again, another aesthetically pleasing beacon. So when you're deploying these in a department store, that actually matters. So you have something that looks nice as you're going through. But they also say that they have a good battery life, about 1.5 years battery life off regular usage. And really, that depends. Under ideal circumstances, yes, you get 1.5 years, 2 years out of a beacon if you have it broadcasting out every 5 seconds at a meter range. Yeah, you could do that. So when my beacons are actually in transit, when I'm taking flights, when I have them at home and I'm not working on them, I tune them down so that they're basically using as little power as possible. But that's not practical when you actually deploy them out. So when you have that beacon advertisement coming out, so the beacon says, who's around me? This is the information, based on the iBeacon specification, this is the information that it shares. Most of the beacons share a little bit more information than this, but this is the base level of what you're going to be working with. you'll have an ID for the beacon, which is has 3 components. The unique identifier, usually used for large group functionality, and then a major and a minor. But here's the best way of thinking about that. Let's say you have a store, and just some random store, and in that store they have 2 departments. They have a candy department, and they have a rock wall climbing department. It's an awesome store. So you have those 2, and you have 3 beacons deployed in each. So the unique identifier, we might have 1 unique identifier that we set for this store. So every beacon will have that UUID. 3 beacons in 1 department will be set to the same major, maybe 1. The other 3 will be set to 2. Then the minors, you'll have 1, 2, 3 in each, and 1, 2, 3 in the other. So basically, you're separating out these majors, minors, and unique identifiers based on their context of deployment. That's the best way to really think about it and how these are made up. Then you'll get transmission power, basically the broadcast strength, the power that was used in order to reach you. That is used to be able to determine the proximity. So we measure power when it hits the phone or hits the device, and that's how we measure proximity. Now, when I'm talking about this information that's shared and the fact that you can broadcast out to phones and wake them up with messaging, first question I always get, and this is typically from the sales departments, is, hey, if we deploy these right by the front of a store, people are going to walk by and we can send them information like, come into our store. We have these awesome coupons. And I go back to my general 1 rule of thumb, which I use for things like this, identity, or basically anytime you're interacting with a person and we're interacting with their personal information, and when you're dealing with their personal phone and interfering with their general life, this rule is very important. Don't be freaking creepy. So it's a very important and simple rule. Doing that, interfering with people on a regular basis by doing that, is the surefire way of getting your application deleted. This is about extending the capabilities of a person as they're walking through a physical space. It's really important to know that that's what you're doing. You're extending their functionality. You are not imposing something on them. So when you're dealing with beacons, that's the only way that they're really going to work. All right, so that's a little bit about the beacons and how they work in general. There's another key piece that we talked about at the beginning, and that's the things that you have to consider when you're deploying. Because the beacons can be a little bit temperamental. They're really great pieces of functionality as far as location awareness, but they can get temperamental. And as we have had in the past with multiple different devices, you might have signal degradation, you might have signal interference. It's the same thing here. Now, first consideration you're going to have is battery life versus range. There's a couple of beacons that are out there that do work off USB power, but the vast majority of them work off battery power. Coin battery cells or AA batteries, typically. You are always going to be adjusting the range of the beacons, the advertising intervals, and things like that in order to preserve battery life. Because some of them are not easy to actually rip apart. This is what happens when you actually have your batteries die on an estimote. So one of the representatives had told someone when I was looking to replace a battery that you have to use your maker skills and pry off the silicon shell right about here and to get the battery. And this is essentially the device here. It's a battery, 3-volt coin battery cell, and then the device itself with the sensors. It's not that easy. I have destroyed 2 beacons doing exactly that, so taking a knife to it is probably the easiest way. Not all beacons are that bad. But this is something that you have to be aware of. If you're going to be deploying them at scale, replacing the batteries is actually an important factor. So, it's when you're deploying these large scale, you want to figure out what the lowest range that you need is, whether it's a couple meters, whether it is 50 meters, how often you need to advertise, so how often you need to figure out where the person is. Do you only need to figure that out every 5 seconds, or do you need to figure that out every 100 milliseconds? These are all questions that you have to ask. If you have a lot of people moving through a space, a lot of potential signal issues, then you're going to want to advertise more often so that you can figure it out and get in a more approximate range. Now, one of the key issues that you're going to run into is signal interference. A lot of these beacons are running at a 2.4 gigahertz range, so you're going to get a lot of different things that can interfere with it. I know it's kind of hard to read, so I'm not going to go through the list, but microwave ovens, for instance. But why would you deploy a beacon on a microwave? I mean, that's silly, but I guess who's close to the microwave, right? But the vast majority of them, as you see, they're all things that are running wirelessly at the 2.4 to 5 gigahertz band range. Things like wireless video transmitters, speakers, etc. All these things can interfere with the beacon signal. When I was actually building out a scavenger hunt game for these things, just something fun to deploy, I had approximately 9 of these beacons just sitting on my desk, and I wanted to see which ones were around me. It would only pick up maybe 6, maybe 7 at a time, and it would kind of switch between them. So sometimes, there's mind you, in my office, it's basically filled with electronics everywhere. My wife hates it, but it's most of us are probably like that when we're deploying that. Signal interference is a real thing, and this is why you have to tune your beacons to approximate range and not deploying them in bad areas where you would have these interferences. So that's something to really think about. The other one is signal degradation, which happens when you're basically broadcasting through things or around things. Now, I saw this really amazing animated GIF once, probably about 3 months back. It showed how Wi-Fi signals extend through a house, and it was basically titled something like "Why You Have Dead Zones in Your House." Have any of you seen that? Oh, a couple of you. It basically will show where the router location is, and show broadcasting out throughout the house via wireless, and how it's bouncing around corners and going through concrete or drywall or something like that, and show how it degrades. Same thing here. We're going to degrade as we go through material and go around material. So basically on the low interference range, you probably lose maybe half a meter. It's not really that bad. You for the most part, you don't really see it. See the major signal issues are things like wood, synthetic material, glass, so synthetic shells. Those things do cost a little bit. So taking the beacon outside of the silicon shell, not a bad thing. On the medium interference range are things like water, bricks, and marble. So most housing, for instance, especially most housing up north, we tend to run into this. A real important one there is actually water. So this is why you don't deploy beacons low. What are people mostly made of? Water. Yeah. So people cause signal interference with the beacons. That is one thing that you have to be aware of. So if you have a large traffic area, it going through people will cost you. And when the signal degrades, what happens is it gives you a larger range. It won't really know exactly where you are. Then on high interference and very high are things like plaster, concrete, bulletproof glass, metal. I run into these problems all the time. My house is just a little bit north of Miami in Florida, and we build everything down there to hurricane standards. So it's all metal frame construction, and we have bulletproof glass or hurricane-proof glass. You could take a small scale handgun to it, small caliber handgun, and shoot it, and it won't break the glass. But when I first started deploying beacons around my house and testing them, I ran into metal, I ran into bulletproof glass, lots of concrete, and it actually causes major issues. High rises, this is what you're going to run into. If you're deploying these inside of office buildings, you run into these problems. Best thing is to have a direct line of sight to whoever's in there. For instance, in this room, you might want to have one right by the exit sign over there. You might have another one over here, another one over there. You might want to adjust their heights slightly so that you can get a better triangulation of signals. If you want to triangulate, get a better proximity. There's usually a whole series of trilateration algorithms that are built into these beacon SDKs to be able to use multiple beacons to get a better approximate range. So one of the things on this trilateration algorithm is really just about improving the signal. It works kind of like that. You might have a couple of beacons that are working in tandem with each other. It's not like satellite signals that they can pinpoint you. It's just going to give you a better approximate range as you're moving through a space, especially if you have a lot of potential degradation or signal interference. Okay, so that is the vast majority about what beacons are, how to deploy them, a little bit of all the things that you're going to run into. It was actually surprising for me the first time I started working with them, all the potential things that you had to know about working with hardware like that on signal issues, especially when you're deploying them in the physical space. The most annoying thing that I run into is people interference. So that's why I mentioned the water one, because when you have the water interference between people in large scale areas, it does cost you quite a bit. And you'll see as people start walking in front of if you have a lot of people around the signal, it does cause some issues. Okay, so what we're going to do now is take a look at how to attach to a beacon. And when we're attaching to a beacon, we're going to adjust its characteristics. So we're going to adjust things like the minor, the major, the broadcast interval, things like that. So these are some of the key pieces that you're going to need when you're actually deploying. There's a couple ways of doing this. We'll look at different ranges. First thing that you're going to need to do in your AndroidManifest file, just a couple of key pieces, is throw in a couple of permissions in there for Bluetooth functionality. So we're running off of Bluetooth, so Bluetooth specification 4.0 introduced BLE, Bluetooth Low Energy, or Bluetooth Smart technology. So it's all incorporated in the same thing. Then you'll include the library through the SK in your libs file, and then include the service here for the estimote. So that's really what goes into your manifest file as a base level. Then when you're messing around with the beacons, when you're changing its data, there are a couple ways of doing this. We'll look at the easy one, we'll look at the non-code one, then we'll look at the code one. So the first thing, estimote has a really nice cloud service for adjusting your beacons. So what it's going to do is allow you to attach every single beacon. For instance, every beacon I own is attached to my user account. That allows me to modify information like its name or any details about it. Now, when I register those, and let's say I'm walking with the estimote application, and I load it up and I can actually find this beacon around me, I can adjust its information directly through their application. So it'll look something like this. If I want to adjust the broadcast interval, it's going to just give me a slider and give me the current power, the range that it'll go. Estimates say that they could do about 100 meters, but for the most part, 75 is fairly high range on these things. That's about what you want to push these things to. But this estimated lifetime is actually quite awesome to see because it shows you how long your battery's going to last. And if you tune those things up, you can burn through that in a couple of months very easily. So you can change everything on this, the minor, the major, the advertising interval, it'll all look like this. That's within the application. Doing it through an Android application is slightly different. I apologize for the people in the back, that is a little small, but I'll talk through everything here on what we're doing. So there's two different ways that we're going to interact with beacon. One's through a beacon connection, which is to manipulate the data. One's through a beacon manager to actually determine where the beacons are, or manipulate the beacons that are in a physical space. Not so much adjusting its information, but just working with them. So let's say we want to adjust the information about the beacon. First thing that we're going to do is set up a new beacon connection. Send through the context. The beacon that you want to manipulate, we'll get into how to get this information, the beacon information, in just a second. And then you're going to provide a new callback. A callback's going to provide a couple of functions for you to actually manipulate, and that is the on authenticated. So whenever the beacon itself is authenticated, when you actually log into a beacon, you can run something there. On authenticated error, if something errors out, and then your on disconnect when you disconnect from the beacon. Then you can just say connection.authenticate, and that will authenticate you against the beacon, and you can start manipulating it. You can disconnect at the end or close at the end to finish up that process. Now, adjusting the beacon settings is actually pretty easy. So there's a whole series of methods on the beacon connection for manipulating that data. So for instance, the write minor, there's also a write major, there's one for write UUID, write proximity UUID. All of these are available for you to work with. What you're going to provide in is a new minor that you want, so the new integer that you want in there, and then you have your right callbacks. You'll have a callback for every single thing where you have an on success and on error that you can manipulate, change your UI, do whatever you want. Send a message up just to show them that it was connected, something like that. So these are all the methods that are available to you in a actual beacon connection to start working with. So there's the advertising interval, how often it broadcasts out saying who's around me. Again, if you need to actually track people very quickly in a physical space, you want to turn this down to, let's say, 300 milliseconds or something like that. If you just need to make sure that someone is still in a space, every couple seconds is fine. You'll have your broadcasting power, basically how the range that it is up to 75 meters or so. Then you can change your major, your minor, your proximity, UUID. Again, that's all your identity information for the beacon. You can change all of that very easily. Now, one of the things that you're going to run into within working with these systems, if you're working with the Android emulator, is that Bluetooth is not supported. So it's not going to be supported through the emulator. There's a couple ways around this. First, easily, use a physical device. So that's the one that I typically do. But there's another cool way of doing it if you feel like getting a little bit into this. You can emulate Android with a BLE connection. So you can start using this as your emulator. So here's what you need. Virtual machine software like Oracle's VirtualBox, a USB BLE adapter that you plug into the computer, and the Android ISO to install Android. Okay, so what you do is you install VirtualBox. You set it up to run Linux other installation. Then you go ahead and install the ISO or load the ISO within VirtualBox, which will start installing Android. You install Android through. Then you close that out, and then in VirtualBox's settings for that image, you set it up to be able to use the BLE adapter. Once you do that and load it up, it should show up in your Android emulator as an available mechanism to be able to use to emulate your code. So that's a way of going about it. I will give you a link to this presentation at the end. It has a nice set of tutorials going through on how to do exactly this, so that you don't have to do it yourself, or that you can just follow the steps. All right. The other thing, and when we actually saw when we're changing the beacon's information, you have to provide a beacon field, right? So I'll show you how to actually pull the beacon information and then pull proximity data from that. It's really quick, really easy. The beacon object itself within an estimote, you remember when I showed you what information is provided with the advertisement, right? It's the identity information, UUID, major, minor, and the broadcast power. Estimote provides a little bit more information, and it's really good because that's the type of information that it uses. Basically, it'll be broadcast power, signal power, and it provides an accuracy rating on how confident it is on actually using one of these beacons. But you'll provide all that identity information, the measured power, MAC address for the beacon, name. The name would be whatever you would set up in the cloud system, so human readable name, and then the received signal strength indication. These typically, this one, measured power, that is utilized to determine the approximate range based on the proximity. Sorry, determine the proximity based on the approximate range. Okay, so this is how you do it. We're going to use the beacon manager for this. And the first thing that you're going to do is set up a region. The region is basically saying the beacons that are around me. There's two ways of doing this. The way that I have set up here, setting up a new region, putting in any unique identifiable string there. Null, null, null here is the UUID, major, and minor. Setting up to null, null, null allows me to pull all beacons in the range and be able to pull any beacons that I find around and manipulate all of them. I could easily change this to a unique UUID major minor and pull a single beacon. So you can do either or. Then we set up a new beacon manager with the current context. And that's pretty much it for setting up the beacon manager. And then all we're going to do is pull ranging information via listener. So we listen for particular advertisements that are going out. We set up a new ranging listener. Within the new ranging listener, we have a couple of, one method that we're actually going to be manipulating, which is on beacons discovered. So as soon as a beacon is discovered, that's when we start looping through that code, and when we actually be able to pull that beacon information. The information that's provided back to that is their region listing. Don't really need to manipulate that all that much. And then the list of beacons. So we can easily loop through all beacons. And then there's a series of utility methods that are available, like compute accuracy, which allow me to pull the pull the meters in approximate range or rate from the beacon that I am. So through this, we now have the meter range, the proximity range of where the beacon is. So that's how you can do it. We've built out scavenger hunt games towards using that. So it stores, for instance, the meter range on how far away you are. As you get close to the beacon, it notices that. It says warmer, warmer, hot, cold, freezing as you're walking away. So you can do things like that. We've had people at hackathons that have built out things they called Connected City. They deployed beacons around a city. And what would happen is they'd be on a building, and then you would have someone who would be blind. How many of you here went to Jefferson's talk this morning? Yeah, okay, a couple of you. You saw the video. It's basically something very similar to that. So you would have someone who would be blind, disabled, that would be going through and have a hearing device. You can also piggyback this. Now the hackers, they piggyback this on top of a mobile device. So it would as you would go towards a beacon, you would provide audio cues back towards where they are, where they should turn, where they should go. So this they call Connected City using beacons. So it's not just about commerce, it's about physical location awareness and extending a person's physical space with online capabilities. So once we have that, once we have the listener set up and all of that, then we can actually get start the beacon ranging. So that's our listener. That's what's going to run as soon as we execute this little bit of code. We would just have connect at the top. So we would connect the beacon manager. Then we would have when it's actually ready, when it's connected, we would run the new beacon connection service ready callback underneath there. And then once that is ready, we would do the just run the start ranging right here through all beacons, which links up to all the beacons around the range. So that's all you really need to do. The listener's there. This kicks off everything, and that's what you need to do in order to get proximity range. Here's a couple of links that are good getting started tools. iBeacon specification, worth a read. It's a quick doc to go through and actually see what's available within the specs overall. As you go beacon to beacon or iBeacon to iBeacon, they're very similar. Almost every single one of them has Android functionality underneath it. Then you have the Java docs. These are the best things to go through for manipulating estimotes. You'll have all the class structures, the methods underneath there that you can start working with. And there's also this cool little thing. AltBeacon is an alternative to iBeacon specification. It works with base level with AltBeacons, but I forget the company. Do you remember the company name? Yeah, so there's a company who created AltBeacon, the AltBeacon specification. They have a couple of AltBeacons underneath there, but really they're the only ones that have them. The reason I'm mentioning this is because AltBeacon's SDK is kind of cool because you can use it with any beacon. So iBeacons, if you're working with estimotes, you're working with gimbal tags, you're working with anything, this is the best one to use as opposed to using the SDK of that particular beacon. So realistically, I've said what the beacons can do, but realistically, what they're there for is extending a person's day-to-day life as they're moving through a physical space. Think about all the things that we've seen from sci-fi movies as people have, as advertisements have popped up in the early Total Recall movies where you have advertisements pop up because they know who you are as you're ranging through. The capabilities of extending what's around you into this interesting little space and extending your functionality as you're moving through with online capabilities, that's really where the cool factor of beacons come in, and really where playing with them becomes valuable. Changing the world around you, changing the physical space around you through small little Bluetooth low energy devices. But really, when it comes down to it, the code and working with them is not complicated. It's not too complicated working with these things. It's all about how to deploy them and the best use case for deploying them. So thank you very much, everyone, for joining me today. This is the link to the slides. I have a link on there towards actually going through the steps for setting up the emulator for with a little BLE USB device. So that'll have all the steps that you need to actually go through that. So, any questions? Yes?
I don't know if it's possible to configure beacons without application, via website, via API.
Yep. So the question is there a way to configure the beacon with a website or
For example, with an hub, within hub.
Yeah. So the way to do it is so there's for instance a couple of the beacons out there. Probably I think the more expensive ones. They come with applications, so you can download an application. For instance, the estimote application. When I load the estimote application, it will find all beacons in range. Oh, you're saying without an application. You're saying website. Yeah, I'm going the wrong there. Yes, you can technically configure them if they provide an open API. If the beacon provides an open API, you can manipulate them at any given time based on the UUID, the major, and the minor. Those are typically the ways that you can connect directly to it and manipulate it. I haven't really seen too many implementations of that in the wild. Typically, you'll manipulate this information when it's in a proximity space around you. I have a couple of questions here. Let me see. So one of the questions is, are the beacons across independent stores? Have they begun being deployed in department stores? And, sorry, this was quite a couple of questions asked before I start. So the answer to this is yes, they're starting to be deployed in prototype environments. So you'll see them typically to extend functionality or to test out things like what you would see with a connected city type of approach. You would see them within merchants who are starting to explore them. There's one company that we work with, that we partner with, called Locals, with a Z at the end. What they're doing is trying to build beacon functionality into stores so that when you walk up to, let's say, a series of shirts, it would know that you're there, and it could provide on a LCD screen information about the shirts, how popular they are, etc. And also they're extending it to provide kind of in-aisle purchasing. So yes, they're starting to be deployed. They're pretty much prototypes right now. Vast majority of them are coming from a lot of startups. There are a lot of department stores who are exploring it as well. Yes?
In terms of determining the range, right, or estimate range, what's the best resolution to go for? Like I'm thinking when we're triangulating, right?
Mm-hmm. I'd say, so the question was, what's the best range that you could kind of hope for, let's say if you're triangulating, using multiple beacons for triangulation. I wouldn't put it anywhere less than 1 meter.
Okay.
Yeah, so 1 meter range is about as accurate as you're going to get.
Okay.
Mm-hmm. Yes, in the back.
You said in your example that the estimated scale could scan for all beacons. Does it scan for only the default estimate UUID or really all beacons?
It's going to scan for all estimote beacons that are around. So whether they're mine or not, this is one of the security concerns, and the reason why I say that any information that's not that you're sharing that's directly tiable to a person needs to be encrypted is because I can technically connect to any beacon. I can technically monitor that information coming through, so that's why you don't want to do that. It was yes.
I didn't understand when I get in range of a beacon,
Mm-hmm.
do I have a pop-up in my app that I have to allow some information? And for each beacon, do I have to allow the same thing for each beacon? Or I can do this one time for one UUID and it works for everything?
So the question was, when you're in range of a beacon, how is it really sharing that information to get a little pop-up on the phone, and then whether you can control multiple beacons in a physical space to just show a pop-up once and then be able to utilize several. So the answer to that is they can be configured. So for instance, if you're in range of a beacon, it's depending on the settings that you set up for your notification settings on on Android. On an iPhone, they're going to wake up based on iBeacon, so they allow them to wake the phone. So you're going to wake up to a specific application. It'll be a little notification that'll come up that'll allow you to cancel out. If you say yes and you interact with it, it'll load up the application and then load into basically however you develop it. Once you have that, and once you either cancel that out, if you cancel that out, you can program it to not utilize all the beacons that are around, or you can just say yes and it can start using all the beacons that are in range. Yes?
I got some gimbals just to try them out. And there seems to be like two modes. One is like a gimbal mode, and you can convert them to iBeacon. Would you recommend to work with which mode?
So for the gimbal tags, there's two modes, right? So so gimbal mode it's the same SDK though, right? That you're working with that. Yeah. So iBeacon mode, gimbal mode. To be honest, I don't know the gimbal mode too much. I know the iBeacon mode.
It seems to be like proprietary. It's tied to their website, and you get statistics and have the badge.
Okay.
So
Yeah. Okay, so if the beacon itself is tied to a website, tied to a cloud service that allows you to manipulate them, I would always go that mode. That's how the estimotes work, because then you can manipulate more about them. The same reason why you would use a native SDK for the estimote as opposed to using an L beacon if you're only dealing with estimotes. It has a clear-cut functionality on how it can manipulate that beacon. Realistically, the hardware is going to be the same. So the power distribution, the signal power, all the information underneath there is all going to be the same. Hardware is the same. It's probably just that keeps functionality.
just that there was something about the UID that was changing always, or the map was changing.
Okay, so it uses randomized UUIDs. So that is a trick. So you're saying that, for those of you who didn't hear, the gimbal, it'll use randomized UUIDs. This is a cool trick I was just talking with my colleague about that can be utilized for some sort of security measures. So swapping out that UUID in different ways means that you can tie this to a web service, and as long as the beacon itself knows that range and how it's changing, and you can control it through a site, it makes it more secure. But this is really a hacky workaround way to making it more secure, but it is a way of doing it. It's a couple of startups, a couple of companies are working with that. So if it does that functionality, that's most likely what it do. Any other questions? Yes?
So if you're using the estimote library, when you get that list of beacons that's in the neighborhood, is it going up to the web service to validate that data, or will it give you that list in isolation, so if you're offline?
Yeah, so when your question was if you're scanning for the beacons, around, will it give you just a restricted list, or give you all of them all around, communicating with the web service? It's just going to give you all the ones that are around. It's basically using staying Bluetooth, what's around me, and utilizing that, pulling that. So you can use it kind of in this offline mode for manipulating. However, if you want to manipulate any data about it, for it to sync to the cloud service and actually showcase that information, it needs the capabilities, the internet capabilities. All right, so let's see. There was a couple of other questions here that someone brought by. How does beacon technology impact advertising industry? Hopefully, so it's just like I was saying during the talk. Hopefully very little. It's information that is typically tracked through these beacons and utilized from it are things like shopping habits, buying habits, etc. We're all probably familiar with all the stories about targets, knowing pregnancy percentages of people. Funny thing is, my wife just got in coupons because our daughter is about 3 years old, and apparently Target feels that it's time for me to have another kid. So that buying habit information like that is actually utilized quite heavily, and can be utilized in advertising. What this means in advertising is, let's say you tie a beacon to a display. it can show information about a particular person in range if you're tracking that type of information. In the case of a proprietary approach like that PayPal beacon, so if you're running off something like this where it's customized to that experience, you're utilizing the service to or utilizing the capabilities of the beacon to manipulate that physical advertising environment. Most likely it will be screens within proximity. I'm already seeing this happening at hackathons quite heavily. So you're seeing people manipulating advertisements through beaconing technology or through proximity. So it's only a matter of time. Okay, I think one last question, yeah?
Wouldn't that cause certain privacy concerns, right?
Mm-hmm.
Like as you're walking by a screen, all of a sudden.
100% yes, it would cause privacy concerns. That's why it's not deployed. That's why you don't see anything deployed. Most of this technology, it's really great to see, but it's going to be a stripped down, dumbed down version of what sci-fi movies end up showing it as. You would need the capabilities of turning this off, and the only way that this would be acceptable in most countries is for it to be to start as a opt-in service. So you'd have to opt into this as opposed to an opt-out. How it'll be in the future, I don't know, but that goes back to that don't be creepy mechanism. It's the hardest part to fight in the industry because advertising like that's targeted means a lot of money. That's the problem. So it's just a matter of finding a good balance. All right. Thank you again, everyone. I'll be around here if you have any questions. Thank you. Let me see if I can dig this thing out. There we go.
Hi, Jonathan.
Hey.
Would you be happy to know that there is a solution without the need to exchange battery and to create a deployment?
So those are usually through direct USB plugs, right?
Actually, no.
Mm-hmm.
We have this solution.
Mm-hmm.
We provide power from Cat5 cables.
Huh.
Ethernet
Okay.
Cat5 cables.
That's pretty cool.